Hello, my name is Adam Gilfillan, and I'm from NC State University. This podcast is part of my final project for my Computer Science 510 class on software engineering. The focus of this podcast is on the JavaScript source code analysis tool, Plato. A link to Plato, as well as all other links referenced, are available in the description below. Plato is a much-needed tool for the JavaScript developers of the world. As popular of a language as JavaScript is, for example, it ranks number 1 by the number of repositories created on GitHub in 2013. It has only a small handful of useful static source code analysis tools. JSLint is one of the most popular of the bunch, and it is simply a web tool available at JSLint.com that accepts copy and pasted JavaScript code. It then returns errors, bugs, and advice about the best practices of the code you submitted. While useful in its own right, this is really the only tool that JavaScript developers make use of regularly, with the exception of JSLint, which is very similar. Other languages that have been around for longer, such as C++ and Java, have a much more extensive static source code analysis tool library available to them. They have a plethora of options to choose from. Plato attempts to rectify this limit of options JavaScript developers have. In my previous blog post, I wrote about what I learned about the open source code that I ran Plato on. I learned some interesting things about many large and small projects, and it is worth checking out if you haven't already. A link to that blog post can be found below. In my upcoming screencast, I will describe how exactly Plato works, and I will even run through a demo from start to finish of Plato. That is, from starting the download through Node.js to analyzing the code base that we'll run it on. It's all very quick and easy. But in this podcast, I will cover what I learned about the tool. To start off, I'd like to discuss a bit about what I learned of the back end of Plato. Perhaps Plato's biggest strength is that it combines two already created JavaScript source code analysis tools at once and then visualizes those reports. The first one I want to talk about is JS Complexity. Plato makes extensive use of this tool, JS Complexity. JS Complexity is a JavaScript source code quality tool that reports on the number of lines of code, number of parameters, the cyclomatic complexity, the Halstead complexity measures, and even a maintainability index. All of these elements are what Plato wraps around in a visual format. The cyclomatic complexity and Halstead complexity measures take in various inputs and return essentially a value that is supposed to tell you how complex your code is. The higher the complexity value, the harder that code is to read or to add to or change, etc. The Maintainability Index is the key value you look at when using Plato. It is the first value you see on the interface. This Maintainability Index was designed in 1991 by Paul Oman and Jack Hagemeister of the University of Idaho. This metric is a formula that uses the average of 3 other metrics as inputs. Those other inputs are the Halstead effort measure, the cyclomatic complexity, and the lines of code. And then it returns a number from a negative infinity up to 171. That's not very useful. So Plato alters that and makes it more readable by adjusting the numbers to be on a scale from 0 to 100. Interesting enough, for my own testing, I have yet to see a maintainability index of greater than 80, and that was on projects ranging in size from 150 lines of code up to 250,000. As far as the usefulness of this maintainability metric, I'll talk about that here in a minute. Now, the other tool that Plato wraps around and visualizes useful information about is JSLint. JSLint is available at JSLint.com. It is very similar to a tool with a similar name, JSLint. JSLint is perhaps the most popular JavaScript source code analysis tool available, used by many companies, developers that use JavaScript. It simply takes a JavaScript program and scans it for errors and potential bugs and spots where the current best practices are not being used. Some of the potential bugs it looks for are syntax errors and leaking variables, which are common points of problem in JavaScript. Plato takes this information JSLint reports on and incorporates it into a visual display. Once again, because Plato is such a visual tool, I believe that to fully understand Plato's usefulness, a visual demonstration is needed. Once again, this will come in my upcoming screencast. But anyway, Plato takes this JSLint data and combines it with the JS complexity data to create a compelling visual JavaScript source code analysis and investigation tool. So now that I've talked about what I learned about the back end of Plato, I'd like to talk about the pros and cons of Plato. First, Plato's front end is impressive. It creates a sleek web interface report that is interactive and investigable. I'm able to navigate from a very macro-oriented level view of my entire project all the way down to JSLint information about even just a single function or line of code. This freedom to investigate allows for the user to gain some potentially useful insight that he would have otherwise missed. Another pro of Plato, and perhaps its greatest strength, is its seamless integration of JSLint and JS complexity. The fact that it essentially does all you need from JSLint and JS complexity in one tool means Plato could or even should be the first option for developers to run to when they need either of those aforementioned tools. Plato acts as the central hub of the useful knowledge gained from these other tools. Now, another pro of Plato is just how simple and easy it is to run. Yes, you must have the required Node.js installed, which is a great library JavaScript tool for both back-end and front-end development. But after that, it is only a simple npm install and one command line away from your first report. It is impressive just how easy it is to run the program. You're able to run it just as easily on a single source code file or on an entire project consisting of hundreds of files. That notion, however, brings me to one of Plato's cons. The first problem I noticed with Plato was Plato's performance on large projects. It performed quickly on small and medium-sized projects, but due to the fact that it's web-based, on large projects, the web interface either loaded too slow or sometimes not at all. This rendered me unable to even get a report generated on Node.js, for example. Although my use in wanting a report of the entire Node.js codebase is probably the rarest of use cases for Plato. So that shouldn't really hurt Plato too much. Another con of Plato, in a more general sense, is the overall lack of insight into your project, perhaps, that Plato provides you with. Aside from the few potential bugs that JSLint may point out to you, and aside from easily seeing a link that more lines of code generally means more errors, not much else useful comes out of Plato. The average maintainability metric score is a nice ego boost if your project scores higher than a friend's, for example. But aside from really low values in this metric, my guess is that no developer really cares what your project's maintainability index is. But overall, Plato is a new tool to the JavaScript developing community, and its usefulness remains to be seen, but is without a doubt an impressive visual web interface that visualizes the useful features from JSLint and JS complexity. To see the tool for yourself, head on over to GitHub and search for Plato, or simply follow the link in the description below. Thanks for your time.